Great. Okay, cool. Let's do introductions. Or who do we continue with? Why don't we continue with Megan?
Awesome. Hey, everybody. I'm Megan. I am also one of the co-founders of Neuromatch, and I am one of the co-creators of the Computational Neuroscience course. So you might recognize my face from some of those first videos.
You
Uh,
were wearing a hat last time I saw that.
yeah, that's true. And actually, when we saw each other just a few weeks ago, I was also wearing a hat, but it was not, I don't have that hat here, but I occasionally wear those hats. The what, how, why hat. So you all should be able to, recognize us from that too. Yeah, we're just really excited to have you here. Thanks for being part of the Neuromatch family, the Neuromatch community. Hope you're exhausted but having a good time. And also, I'll take this opportunity to say I know that there are a couple conferences that are coming up that some of us are going to be going to, but that all of you are probably going to also. So CogSci is happening about this time, or did it just happen? I don't remember. But CCN is coming up, and there are lots of others coming up. So find a way to put Neuromatch somehow on your badge when you are at these conferences, and you can actually meet other people who went through another Neuromatch course. So I will be at CCN in Amsterdam, and so if you see me there, come up and say hi. I think that that would be really fun to get to meet some of you in person.
Yeah, why don't we continue with Gunnar?
Sure. Hi, everyone. Very happy to be here. So, as you know, you've been tortured by me for mostly in the first week, I guess. Hopefully, you've learned lots. Meta science or like thinking about how to do science is always hard because you sort of like have to step away from the nitty gritty stuff. But it's super, super important to get projects right. So, I really hope that you spend some time, spend some thinking about it. Good planning up front makes a tremendous difference during the execution of the project.
Cool. Why don't we continue with Ella then?
Hey everyone, I'm Ella. I have been involved in Neuromatch Academy since the very first summer, so it's really exciting to be back in a room with students for the first time in a while. Yeah, I was very involved in the Comp Neuro curriculum for the first few years and was served as the executive director of Neuromatch Academy for a couple of years. So yeah, it's really exciting that you're all participating in this course and here, and definitely want to echo what Megan says. I love nothing more than at conferences, actually meeting people that took Neuromatch. So if you ever see me in real life, please come and talk to me.
Yeah, and conferences and summer schools and meetings and just about everywhere where I am, I'm meeting people from Neuroscience. I was briefly going to talk about something that Megan and Gunnar are also involved in, which is, of course, by now a lot of former Neuromatch participants are starting to enter the ranks of professors. And so this year, for the first time, we are organizing a summer school only for professors, just to like keep the vibe going. That will be in person, but it's kind of like a whole chain of events that ultimately, I mean, Neuromatch has the computation neuroscience and the deep learning and the neuro AI and the climate. So there's by now people who have like lined up a whole bunch of courses sequentially, and this is just wonderful to see.
Yeah,
And
and
then
in that course, we're not going to talk about any computational neuroscience anymore. We're going to talk about all the things that you don't get in Neuromatch Academy right now, which is how do you do all the stuff that professors need to do aside from the actual research?
Yeah, no one ever taught me anything. Not like literally when I started as professor, I had not the slightest idea of what I was supposed to be doing.
That's terrible, really.
how to manage a research project. There's also opportunities to be involved in Neuromatch even after the end of the summer school. So we also have our Impact Scholars program, which is kind of halfway in between the summer school that Konrad and Gunnar are talking about and that we'll be running for new professors or young professors in the field. But we have our Impact Scholars program too, which is you can continue on with some of the projects that you've been working on. I'm sure you guys, Courtney, you've probably told them all about this at this point, but maybe this is a good opportunity to highlight it anyway. Um,
And in fact, maybe this is a good segue. So Nikolai Safronov ask the first question, which is, can you tell us more about the IS NMA program this year? Just
Yeah, that's
talked about
exactly
it, but
right.
tell us
Yeah,
more.
so I mean, I can say a little bit. Courtney's, I think that probably the best person to answer that question too. But it is this opportunity to continue on with mentored projects, and you get to keep, working with a group or work with a different group, right? But then you get this little micro publication at the end too. So it's kind of even beyond just the poster sessions that we do for the projects here. And of course, you can always keep doing your NMA projects anyway, right? You can keep doing that and submit them to conferences, all that stuff. But this is an opportunity to stay engaged with the Neuromatch community to do those things. And I think it's really cool. So, Courtney, there's probably other stuff that I'm missing here because you're the one who actually runs this now. So,
Yeah, definitely. I feel like that was a great overview. Yeah, the Impact Scholars really came out of, I feel like, to the point of you all sharing about your kind of extension for professors or like early career professors. This was also an extension that was from the community needs. So we heard from our students, from our TAs, they wanted additional, more extensive research opportunities. So some folks in our Climate Match Academy actually piloted this, and we've been able to expand it. So yes, this is an expanded opportunity. It's a 6-month research opportunity. You can have a team from 2 to 4 people. The applications will open after the academy, and there'll be plenty of time for you to be able to see what other projects are available, understand which other people want to apply. So you can self-organize your group. It could be people that you work with in your pod now, could be different people who are interested in a project topic that more aligns with your research interests. So Viviana, who I know most of you have probably heard or met, will be creating some channels in Discord for you to help organize with each other and to create those proposals that will eventually get reviewed. And then for folks that are accepted, it will be a 6-month commitment, and you'll have a dedicated mentor over that 6 months. So you can continue doing that research, and you'll do that micro publication as well. And it's been super awesome. Last year, we've had at least one group will be doing a poster session at SFN with the research that they did. We've had other folks do complete, like, full publications as well. So really cool. We're super excited about it and excited that people are excited to apply. So yeah, thanks for that question.
there's a related question too, which is, will there be a follow-up for the Impact Scholars cohort this year, like a wrap-up meeting or something like that? Do you know, Courtney?
Yeah, that's a good question. I don't actually think Viviana has anything planned, but that would be super fun. I feel like it'd be cool. We did do the seminar presentations back in March, but it might be kind of fun to do another kind of get together so you all can share if you continue to do research. So I'll let her know that that might be something of interest.
I think that's a great idea.
It might be really cool for the new cohort to see what the old cohort has done, and sort of, get a feel for the amazing work, the kind of achievements that they can accomplish, and all this kind of stuff. It'll be a great motivator.
I like that too, because it kind of revives some of the feeling that we had when we were running the Neuromatch conferences. So, for those of you who don't know, Neuromatch had some of these online conferences too, kind of during the pandemic and immediately afterwards. Then everyone got a little tired of Zoom, and so we decided not to do that quite so much anymore. But this would be an opportunity, I think, to have some, we could record the talks and we could have them attached to the micro publications. So you have, you can go to the micropub and then you can see the project presentation that goes along with it. It's kind of like what we did for the talks that were at the Neuromatch conference that had a preprint associated with them. And so then it was kind of attached to the preprint. This is also, I think, for those, for all of the students out there and the TAs, this is an excellent demonstration of how NMA really runs, which is someone has an idea and it's like, ooh, that's a good idea. Let's see how we can make that go. So if you've got ideas for how the Impact Scholars Program or just NMA in general can be improved or changed, even better if you want to come help build it. But if you've got ideas, share, right? This is what this is all about. This NMA isn't just us building stuff for you. It's all of you. So,
and there was a saying in the first year that went and don't worry, it won't be much work.
And some people attribute it to me, but that is entirely misleading.
Gunnar, does your shirt say that on the back? Because we had shirts that said it won't work on the back.
I'm not wearing that one right now.
So I was going to, before we go into the rest of this hour, I was going to just set expectations a little bit. So you're all here because it's a chance to ask us questions. And you can ask any question you want. Nikolai is asking the thought amazing question. But for everyone, you can ask us questions about career things. Like, how do I meet people? How do I network? How do I know which professor I shouldn't work with? Like all those questions. You can ask us content questions. Like how should I think about this branch of neuroscience? Or where can I learn X? You can ask us teaching questions, like how could I possibly acquire these skills? You can ask us strategic questions. How can I make Gunnar, I see your hand up.
Well, I was going to ask a question because I like asking questions too. If can I?
All yes.
So I'm sure I mean as a student I would have that question. Like during the academies, you learn all kinds of cool scientific stuff, right? And it might be really useful for the projects that I'm working on. Personally, if I were a student, or even now, I still learn from the academies nowadays, believe it or not. But does it buy me anything else? Does it have any other advantage? Does it does it have a real impact on the job market? And I'm curious whether anyone, maybe Ella, maybe Megan, have a bit of a feel about that and would mind sharing that.
You want to go first, Ella?
Right, Gunnar would have a feel for what specifically?
The impact of Neuromatch Academy on careers, not just the science per se. Hopefully it makes the science better, but also if someone shows up with Neuromatch Academy certificate on their CV, does anyone recognize that? Does it make a difference? And Ella, you've been director of a program at the institution,
Yeah.
and a good institution. So maybe you have seen some of that, or maybe not.
Yeah. So yeah, I'm now a research scientist, but I was in charge of a lot of comp neuro educational programs for a while. So I have experience of this. Yeah, I mean, obviously it depends on the person who's reading your application. I will say in computational neuromatch, I would say that Neuromatch Academy is very well known, I would venture to say. Like a surprising amount of people recognize me at conferences like Cosine from just being in the videos of Neuromatch Academy curriculum and so on, or being involved. So I think that I think that it definitely helps to have it on your CV. To me, it tells me that someone has been so excited about this that they've spent 3 intense weeks of their summer, which is, maybe the most fun weeks, just deep in computational neuroscience. I think the project especially can also be a really good chance to if you haven't had enough kind of exposure to research in other contexts to actually be able to talk about a research project you've worked on, and also just the networking of meeting people, including people in your pod, your TA, I think can also really help. So I've definitely seen Neuromatch Academy on people's CVs, and I try not to be biased because I'm involved in Neuromatch Academy and I defer to other people on the selection committee, and they are excited about the fact that people have been in Neuromatch Academy. So I do think it definitely helps. And, it doesn't mean that you have understood every single thing in the Neuromatch Academy course. It's a lot coming at you in 3 weeks. Just the act of having gone through the content and even getting the high level overview, I think really makes you much more informed and able to kind of talk to your next potential mentor and yeah, get excited.
So I think there was a related question to what you just said, Ella, which is Neuromatch Academy is so much stuff. How can you successfully catch up ever? No, because realistically, most students don't grok everything that we teach. What's your experiences? What's your thoughts about how to catch up?
Yeah, I mean, I think that we emphasize this every year, but you really don't need to learn every single detail of every single day. That is impossible. I probably don't even know every single detail of every single day, and I've been in comp neuro a long time. So it's really in part like try to get the bigger conceptual ideas, even if you don't understand every equation. Think about how it might be used in neuroscience. Think about what's catching your interest the most, and those are the days you can especially come back to and think about if there's research you can pursue in that. Um, but it's easy to say don't stress, but that really is the advice is it's better to try and focus on the bigger picture of what you're learning than kind of miss the forest for the trees because you're so focused on understanding every variable and every equation.
Totally. Like I like to think about Neuromatch as like a cooking class plus a tasting menu. So like you get to take you go to a cooking class and you get to learn how to make like a few things, right? But then you also get to taste all these interesting flavors and styles and like new things like that. And you get to discover what you like, what you want to incorporate into your own kitchen. And this is the same kind of idea where you don't have to know how to make everything when you leave that one cooking class, but you know enough that now you can go buy a cookbook and you can like follow along and you've like learned enough of the techniques that you can kind of pick it up and watch some more YouTube videos and like take another class that's more specialized and that kind of thing. So like I also could not do all the stuff in the comp neuro class, even though I helped develop it. And I certainly can't do all the stuff in the deep learning and neuro AI classes. And that's okay. But it's enough that I now have the vocabulary, right? And so do you. You've got the vocabulary and the resources and just enough experience that now when you go pick up a theoretical neuroscience textbook or you go and take an advanced class, you learn it gets you a little bit closer. It's like a scaffold. So do think about it like a cooking class. You're not going to become a master chef, but you're going to be able to follow along a lot better. And you get to taste some tasty food along the way. And that I think will help, drive your enthusiasm for it. And when I see Neuromatch on CVs and on resumes and applications, that's what I'm seeing too, is not that like you're an expert in all of this stuff. It's that you have enough initiative that you took the time to go do this, that you are self-driven, that you're self-motivated, that you powered through, even though you didn't understand everything. And that's the kind of attitude that you need to succeed in doing interesting stuff. Like ultimately, research is about asking questions that no one has asked before, that no one's asked in that way before, or trying to answer new branches of research to push the edges of humanity's knowledge about stuff. And having the right attitude and enthusiasm goes way longer, way farther than just having like just the technical skill. And NMA teaches you that too. It teaches you this like tolerance of uncertainty, of being in places where you don't know all the answers, where you can't pick up every detail because it is moving fast. But you learn how to tolerate that, to embrace it, to enjoy it, we hope. And then that's an attitude that is going to carry you way farther than, a particular technical skill. So don't worry that you don't have everything. Neuromatch on a CV says, I've got this attitude that makes me hungry for more. That's what I see. And I think a lot of people see that too.
Yes, great. Why don't we continue with another question here? Um, uh, this is hold on. Let's read the newest question, which is by Malav Shah. I enjoy the format of the summer school because it's my role to pick up right stuff I want to learn in detail. NMA provides detailed materials work for me in that context. But beyond learning, I was also expecting to interact with experts in various fields to get to know their experiences, especially as a PhD student who's trying to figure out a career path in research industry. And Malav emphasizes that they're a deep network student. So, Megan, do you want to take this question?
Yeah, I think that we try to do some interaction here at NMA with experts in the field. It's hard to do live 24/7 around the world in the summer school context. In the past we did do more live stuff, and we found that it was just so massively exhausting for everybody that it took away from project time and that kind of thing. We're thinking about trying to bring it back, though. That's one of the reasons why we have these fireside chats this year that we're bringing back. But I think also like take this as an opportunity to have a conversation opener with anybody that you would ever meet at any other opportunity, or conference, workshop, school, guest speaker who comes to your institution, right? Like go up to that person afterwards and say, hi, I was, in Neuromatch, that kind of thing. Because now you've got the vocabulary to do that a little bit more than maybe you otherwise would have. So I think that this is the beginning of the networking, hopefully. But I will also say that the people in your pod and your TAs and the people in your megapod, there was a question about megapod somewhere in that Q&A as well, that those may not be the big, fancy, famous experts in the field right now. But if they're in NMA with you, there's a real chance that you all are going to grow up and become that together. And so, and then you get in on the ground floor and you guys are just like best friends for life already. So, look at the people around you too. Those are going to be the experts and the senior people in the next 5 years.
Yeah, I would like to add to that real quick. So summer schools are amazing, not necessarily because you meet all fancy professors or something like that. I mean, that can be a nice perk sometimes, but ultimately, I think the closest and strongest relationships are built with the peers of your pod during the group projects, the long night sessions, the sweat and the tears and all this kind of stuff. And I'm not just saying that randomly. I know of multiple cases where long-term collaborations have been built after a summer school because people have met at a summer school. They clicked, they worked well together, they enjoyed working together, and off you go, 20 years worth or more, whatever, of collaborative research, right? So don't underestimate that. I think this is a really important factor.
Yeah, I mean, like I wanted to like, I like being like clear about the real problems as well. Like deep learning is a really, really difficult field at the moment. Why? It didn't exist as a field 5 years ago, 10 years ago. It barely existed 10 years ago. I used to go to Neuromatch when it was a tiny conference. Now I'm not even going anymore because it's too big. And in that sense, the age distribution just looks like really, really bad. It's kind of like the people who are like above age 50 who've been in that field for 20 years, like they can probably all fit into my room here. And this does produce a real problem. So on the neuro side, we can credibly find a good number of mentors that get involved in our project. On the deep learning side, it's just like the world doesn't give enough copies of Jan LeCun and Joshua Bencher to like all these spots. And in that sense, would it be better if we could? Would it be better if anyone could? Like, yes, it would be much better, but like it's just not the structure of that field at the moment.
But I'd also like to kick it back a little bit, that question. So originally, when we created Neuromatch Academy, we had lots of like contact time between like course instructors, etc., and you guys. But very quickly, that sort of like became not very interesting anymore. and certainly in the last 5 years, like our attitude towards being constantly on Zoom, etc., has changed dramatically, right? We don't like the online stuff so much anymore, etc., etc. So as a result of that, Neuromatch Academy is constantly trying to innovate the way that interactions work, the way that we deliver programs, new programs like Impact Scholar programs get born, etc., right? So if you have specific ideas because you think this is missing and this would really benefit everyone, please share. The only thing, all we want really to do is to improve the experience for you. And the more input we get on how to do that, the better it'll become. But it is a rapidly moving field as well, right? So we're constantly trying to like adapt and catch up based on sort of like the current feeling of what's desired and what not, in this ever-changing climate.
So I was going to pivot away from like who or what Neuromatch is a little bit. And I think I want to read the question by anonymous attendee because I think this is the maybe the most important question in the universe if you're a student, which is what signals tell you a lab research group will be a healthy place for students? Besides publications, how should I judge whether PI mentorship style is a good fit or that a lab culture is right for you?
This is a huge question, and this is maybe the question because if you're thinking about going into a PhD program in the United States or Canada, that's going to be 5 to 6 years of your life as a commitment. In other places, it's going to be 3, 4 years, but it's still a big chunk, right? And so and it's going to scientifically and personally direct kind of the trajectory of the rest of your life. Now, I don't want to say that to scare you because, of course, like I went and did a PhD in kind of thing A and then ended up doing thing B as a postdoc and moving on, doing things differently. But it still matters a lot. I think so. There's a couple things that come to mind immediately. One is actually talk to the PI, interview them just as they're interviewing you. You want to ask, like, what is your mentorship style? How engaged are you? And there's no good or correct answer to this, really. It's about whether it fits with you. So if you prefer a very hands-on mentor who is going to meet with you, a couple times a week and like really going to get engaged and read your code all the time and all that stuff, you're going to be a different kind of student than someone who wants to be more independent and who wants to go and do their own thing and meet, every few weeks or something like that. And this will also change across like the course of your training, right? Initially, you want to meet with people more probably, and then you become more independent. But if your mentor's style is very hands-on, very engaged, and you want to be more independent, you're going to be really annoyed with having to meet with this person all the time. Um, and so I think, talk with your PI, your potential PI, ask these questions. What is your mentorship style? What kinds of interactions do you see as being the best for you? Do you want someone as a PI who's going to be more of a supervisor? Do you want someone who's going to be more of a partner? Do you want someone who's going to show up occasionally and tell you you're doing everything wrong and then disappear? These are all like valid answers to this question. And then also talk with current students and alumni. You have to do that because the answers that you get out of your potential PI are just their perspective. And so you need to hear from current and former students what it's really like. And those can be really, really informative. And ideally, you would have these conversations over Zoom or live in some way so you can really get honest opinions about out of people. And this is really important. So when I have students, or potential applicants want to come and work with me, I put them in touch with my current and former trainees to the extent that those folks are, around and willing to
And
engage.
if professors say no to that,
That's a huge red flag.
don't join them.
Yeah, bad, 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 bad.
Ella.
Yeah, absolutely.
I think all of that's really good advice. I would just add maybe two things. When you talk to current and previous members, especially previous members might be even more willing to be honest. I think really specifically ask them their favorite thing about their lab and their PI's mentorship and ask what they could change if they could, because sometimes they won't volunteer anything negative, but if you force them to at least say one thing, you kind of get a sense of what the maybe issues are. Um, Also, I totally agree that students have different needs for training, and it's more about the right fit than there being, one PI that's perfect. I will just say that in my experience, students overestimate their desire for independence. And so I would just be a little wary of that. Like, you are training in a PhD, you want a professor who you speak to sometimes.
Yeah.
And so I know a lot of students who are like, I know what I want to do. I just want to do my own thing and I don't want to ever have to talk to anyone. Like, I would say that please question if that's actually going to be useful for training and learning.
Yeah, you don't want someone who really is just kind of, absentee and shows up every few months and like gives you some feedback or something. Yeah, that's
well, another factor. I mean, it's a very high-dimensional problem, right? Another factor that you might want to look at is sort of like the trade-off between hands-on training on particular things, which is typically well done by like more junior faculty members, and sort of like steering you broad picture, positioning you in sort of like a career space, which is often done slightly better by the more senior influential ones. Now, the problem is that the more senior influential professors also have huge labs typically, and therefore very, very little time to actually train you directly, which often means that if you're lucky, you get trained by the postdoc or more senior grad student or whatever in sort of like a hierarchy, but you don't actually get much face time with the professor. So there's all these aspects you got to think about. What do you actually want out of this experience? And as everyone said, like talking to the former or current students and how this practically works is really, really informative.
Someone put in the chat too, Nikolai, put in the chat, sounds like you need two PIs. And like, actually, that can be a really good solution. So this is another question you can ask to your potential PIs. Are you open to co-mentorship? And so sometimes like there's actually formal systems in place at a given department or school where like you can officially have two mentors. This is something that's available in my department right now, that you can have, on paper, two people who are actually like your co-supervisors, and that's great. Then you get different perspectives. Now that you end up having two academic parents who also might not agree with each other on everything, and then you have to deal with that. But sometimes this can be a really good option, or you can have like a primary and a secondary advisor, and that can also be a really good option. And this is also why you have a committee too. You don't just have your supervisor. You should also talk to the other faculty on your committee or in the department in general. Like you don't want a supervisor who will try to restrict your movements. That's another red flag. You don't want someone who's going to say like, no, you're my student, you can only listen to me. Like that's not good. So sometimes multiple supervisors is exactly the right answer.
And I mean,
Especially if they're complementary, right? That's what you kind of want, because then you can potentially learn more. Sorry, Conrad.
Ella.
Oh, I was going to say, I might be the lone voice here, but I'm a little skeptical of co-mentorship. I think that often I've seen it maybe go wrong. So I just think if you're doing it, you want to be, I would advise having primary and secondary mentor. I think most people end up in one mentor's lab talking a lot to the other one rather than being equally co-mentored. I think it's difficult to have two homes. Also, if you're co-mentored but no one's really like your primary mentor, I've seen students that sort of get lost in the cracks. Like
That's true.
no one really knows who's keeping track of them. And so I think it can be a really good thing, but I just think you want to set yourself up for success by maybe like thinking of it more as primary and secondary, is my opinion.
And I mean, to share the professor side there, I mean, I'm one of these old, like maybe overworked professors, and my students see me every week, but I'm also traveling frequently. So in that sense, they see me less than every week. And what I usually do is, it's not that they're like come in as a double mentored student, but like I bring them in and then we add a second supervisor for the subject matter expert. So it's kind of not just like it's two people, it's more like two people built around the student's project, which in my lab seems to be working well. I want to move on to the next question. So this is a question by Se-Yun Zhang, who asked, it seems that many comp theoretical neo PhD programs are looking for undergraduate students coming from physics, math, CS majors. I can suddenly confirm that. What are your advices to students coming from non-technical majors like psych, neuro, philosophy, given that they cannot afford to complete another undergrad degree or navigating comp theory neo PhD applications? Who wants to take a stab at this?
Start I mean, you're here. That's the first good step. Learn. This stuff can be learned. I've seen, like, personally, my home department is a life science department. So like one of those soft sciences, if you want. About half of my trainees have gone through that program, and they essentially have zero computational ability when they graduate from that program and join my lab, and then they learn. And people often say, where there's a will, there's a way. And that's true. And it's not an easy way. Like learning math, learning physics, like the hard sciences requires a lot of dedication and practice, computer science as well. And you just got to commit to that. But it's absolutely possible. And Neuromatch Academies is one of the ways that can help you to achieve those goals, but it's not the only one by far.
Yeah, I'll add to that too. So my group is really interdisciplinary here. We're in a cognitive sciences department. I've got students who come everywhere from, mechanical engineering and artificial intelligence through some students who have a background that's basically philosophy, actually. And everything in between, people who come from psychology and neuroscience. And so in this way, like having an interdisciplinary group works because they can also help each other. And so there are cases where you might think that the people who come in with technical backgrounds are just like already better or something like that. And that's really not always the case. So there's these complementary skill sets. One of them is in kind of theory and theory motivated thinking and experimental design and all of that stuff. And if you come from an engineering background, you haven't been trained in that necessarily. And if you come from a psychology background, you may have less experience in the computer science and the statistics and the mathematics, but you're going to have a lot of different relevant training for experimental design. And I'll also give you an example from my own life. So I was a cognitive science undergraduate major, which meant that I took one statistics class and one programming class. I have not formally taken calculus since I was in high school. And yet here I am. And I was previously a bioengineering professor, and I'm a professor of cognitive sciences. So if I can do it, so can you. And so but the way that I did it is that I filled in a lot of the gaps myself. I watched a lot of YouTube videos. I watched a lot of like linear algebra videos from Gilbert Strang. Like I learned that stuff, just I didn't take a class on it. And so NMA is another case where you're constantly having to evaluate, uh, am I learning this? Did I not get that? Did I get that? So this kind of metacognitive skill that you're building is really important because that will help you say, well, here is the gap in my knowledge. And so now I'm going to go find something that's going to help me fill that in. So don't think that you're immediately at a disadvantage just because you're not coming from physics and engineering and that kind of thing. You'll have a different kind of disadvantage, but so will they.
Oh, Ella, after you.
No, go ahead.
So I mean, like I do run a computational lab, and I think like there are three different labs. There are labs that like primarily see their goal as driving computation. These labs will very, very, very rarely hire people who don't already have a very strong computational background. Then there's a set of labs who basically don't do anything computational. They can't teach you anything. And then there's like the crossover labs that hire like some people from both sides. Like think about Gunnar and Megan. And there was a time where I was hiring like in both sides. Um, it's those labs exist. Those labs is like think of it from your own journey perspective. If you make a move that is so big that what you learned in the past is basically useless, then you will not have a good time. So if your background is mostly like wetware biology, you will not be good being in a lab that mostly proves properties of algorithms. Now, like maybe you learn that your love is about proving things about algorithms. The way to go about it is then do small steps that get you into the right direction, or like move from a pure wet lab environment to one where like people also build like some cool data analysis algorithms. Move from there into not only cool data analysis algorithms, but also some proofs. And then you'll be at the right place. But like, I think this is important to never forget. Like, you should only ever in your life do steps that are such that most of the things that define your current skill set carry over to that next step. And the way to get from A to B is just like lots of little steps. That's how I get everywhere where I wanted to be.
Yeah, you can't go from 0 to 60 or 0 to 100 like overnight, but you can find little steps to get there for sure.
And just on a very practical note for like, this is country specific, but for applying to PhD programs, which was the question originally mentioned this, I'd say a lot of amazing neuro programs have access to really great comp neuro labs, but they're not specifically comp neuro PhD programs. And they have rotations, and you have, at least in the US, and you have a year to really learn more computational skills, to maybe go into more computational rotation in your last year. So maybe consider that as a small step instead of trying to go for just pure comp neuro based PhD programs. And I'd say that neuro programs and comp neuro PhD programs also really value neuro knowledge. So don't underestimate that. Like that I see as just as fundamental for doing computational neuroscience.
Yeah, my PhD is actually in psychology. That piece of paper says psychology, but I did cognitive and computational neuroscience as like my track. So there's definitely options to do that. So don't restrict yourself to programs that are entitled computational neuroscience. There's lots of ways to do this kind of work in a medical school, in a wet neuroscience program, in psychology, and lots of different things.
And maybe we can also briefly touch on Sahil's questions here. Like there is about paths, like how to choose things. There's a set of things that you're good at, and then there's generally a direction, even if there's a lot of uncertainty. I think if you sit down for a while and you ask yourself, what's my general direction where I want to go? You will be like, okay, maybe I want to be more computational. Maybe I want to be more disease related. Maybe I want to be more molecular, and then kind of like move from your skill set into the direction where you want to be.
This can also be like if you're applying to grad school now, this is exactly the exercise you should be doing when you're writing your statement of purpose anyway. Is like, don't have it be a list of things you've done. Have it be a coherent description of where you want to go and how the things that you have done so far have set you on that path, have taken those little baby steps that Conrad was talking about, right? So like if here is your goal way out there, this is where you are now, and this is where you were a few years ago. What have you done to take steps towards that goal? And probably you didn't know that that was your goal when you took some of those steps. But now, if you look back, you might see that in fact that was the goal, or you can see the trajectory. And so if you go through this exercise, then I think that will help kind of clarify which paths are the right ones to get you to that goal. And the goal shouldn't be, I want a PhD. It should be, I want a PhD because it will help me answer this question, or it will help me achieve this career trajectory, or this, that, and the other thing. The PhD is the first thing, not the end state. And so if you do this exercise for like, why do you want the PhD? And it can't just be because I want to be called doctor.
But I think that it can be because you just love neuro research, even if you don't know exactly that you want to be a
Yeah, you don't have to have a career in mind necessarily or a specific question, but having a general understanding of the types of questions that you want to answer is, I think, a really important exercise to go through.
I think Nikolai's question is also slightly related to this. Like, is there ageism? Like,
Mm.
to be clear, like there are lots of people who have prejudices against people who say don't have a computational undergraduate degree. There's also plenty of professors who have prejudices about age, and yet some of the best professors I know, like, basically entered neuroscience after a successful career in software engineering. Now, like these crossover people exist. Good professors will look at the people and the mission, and there will be people who have ageism, and we can't like get rid of that as much as it would be nice to do so. Great. Now maybe we should briefly take the anonymous question, because I think it's one of the big questions in the room, in particular for people working at Harvard, I guess, which is what's the opinion about comp neuro and science grants in the US in the next 4 years? I think we all agree on that, but maybe like let's spend like 2 or 3 sentences on how we feel about this.
Candidates, I'm being silent here.
I was like, I'm not allowed to talk about this.
No, I mean, Conrad is referencing that I work at Harvard, and yeah, we've been in the news quite a bit around this. And yeah, I mean, I don't have much to say other than it's very disheartening. And I think that it is going to put a significant dent in the US's ability to do science. And I'd love to sugarcoat it, but I really can't. Um, and so I just think it's very unfortunate. I think that it's exciting to see scientists come together and try to figure out ways to do research anyway. And I personally think that you can ask and answer really interesting research questions with, less funding. I think there's really cool research being done at universities that have far less funding. So, I'm not totally hopeless, but overall, yeah, it's very unfortunate.
Maybe to leave you in the hot seat, Salma asks if you can recommend 1 year Comp Neuro programs that you mentioned.
Yeah, so if actually this is a great opportunity if you don't know about post-bac programs and you are finishing up your undergrad but you don't have much research experience or you need to take more courses. Post-bac programs kind of bridge the gap between undergraduate and applying to PhD programs. Often they're designed to help you apply to PhD programs. So there's more and more coming up, especially in the US, although unfortunately they have also been impacted by the grants we just mentioned. The institute I work at, the Kempner Institute, has a 2-year post-bac program for Comp Neuro. I think Columbia has one. There's lots. I can't say them all now, but it is a whole form of program that some students are not aware of and that can be really useful.
Now, I want to say something bad about these courses as well. So, these courses tend to be very expensive for a relatively short period of
Oh
time.
no, post-bac. Oh, sorry.
Oh,
Post-bac. I should have emphasized that post-bac programs, unlike master's programs, usually pay you. There are, of course, also master's programs. Those are expensive.
Yeah, the master's programs tend to be very expensive. And I think their main goal is as a certification agency. Like, because let's say you have a PhD that no one, no, you have an undergraduate at a place that no one knows about. Getting into one of these master's programs is basically just a way of attributing the name of a university to your CV, and they sell it for $60,000 a year or something. Think about it however you want, but like I have my worries about the sanity of that approach.
I actually totally agree. If someone wants to go to a PhD program, I wouldn't necessarily recommend a master's program. I think just trying to get research experience is maybe better than that. But a post-bac program is the best of both worlds, so that's why
There are some PhD programs that require you to have a master's, though. Like in the States and in Canada, you don't have to have the master's, you can go straight in. But well, yeah. Yes. Technically there are, but
In Canada, there is direct admission, but it's
yeah.
Not the rule.
Right. And the same in the United States. But in other places, like in the United Kingdom or in Europe, typically you would need to have the master's in order to be eligible. And the PhDs are shorter as a result. They're like 3 years long. And this is not a hard and fast rule. There are cases where there are exceptions made, but it's different. So look at, wherever your home country is or wherever you want to apply, look at what the requirements are. I will say though, it came up at some point. So post-bac and master's, yes, this is a great way to get specialized training. And if you can work out the money, you can get that specialized training for hopefully like not so much money. Don't go do another bachelor's degree though. I really strongly recommend not doing that because most bachelor's degrees will have also distribution requirements again. So you have to go take freshman English and you have to go take PE or whatever. So like don't do that. That doesn't really like help you. There's a lot more efficient ways to get the specialized training in and to fill in gaps. And there are some programs, even especially master's programs, that will accept students what's called with deficiencies, which means that you can get into the program, but if you don't have a certain set of upper division classes, they'll let you into the program on the condition that to stay in the program and finish up, you have to take those upper division classes at the undergrad level as part of your master's training. And so typically, at least, so I live in California, and I know that these programs exist in the California State University system, where you can get in with deficiencies, and then they'll like have you do the upper division, like, advanced statistics or machine learning or, math or whatever as part of your master's program because that's like a condition of your acceptance. So sometimes you don't even need to go get a post back. Sometimes there's these ways of getting around it too. So there's lots of pathways to do this.
So we're basically running out of time. I want to switch at this time into a lightning round. So everyone who's on the panel, look at the next few questions. I'm gonna just read them and like we answer them in like 20 seconds max. Nikolai asks, can you tell us about how to find a long-term mentor? And my answer to that is specialize on something that you find interesting, that very few other people find interesting, and then just ask the people in that area. But you need to be very specialized and you need to be very clear in like a 3-line email why that person needs to mentor you, why not someone else can do it. Next question. We have a question by Si Hyun who asked, what are the research trends in neuroscience?
Everything.
Yeah, that's a hard one to answer quickly.
I think I have a quick answer. It's like scaling massive amounts of data, making sense of massive amounts of data is the biggest trend.
Okay, can I answer 2 seconds on that too, which is related to the research funding answer too? Big data and reuse of existing data and curation of existing data is becoming a huge deal. And so I do think that that is a big direction that has two prongs. One, it's where we need to go because we've got all these piles of data that can be reused, and data are expensive to collect. And so as research funding in the United States changes, a stronger emphasis on curation and reuse of big data sets, I think will be a direction to go in.
Great. Sarath asks, how does normalization happen in neuroscience?
Context, normalization.
Yeah. Normalization can improve generalization. How does the brain implement it?
Oh, that's specific. Sorry.
Sorry.
I'll answer this from the perspective of divisive normalization, I guess, that there are lots of different circuits that can engage in divisive normalization, and that depending on whether you're a fruit fly or a mammal, the different kinds of circuits are going to engage in divisive normalization. But I think that's not exactly the answer to the question.
We just have a preprint out right now on like essentially multi-sensor integration / marginalization with neural networks.
Go read Gunner's paper.
Oh,
There's the answer.
Asim asks, at which point of time should one teach the analogy between mathematical concepts and neuroscience?
I think analogies are super useful. Yeah, I would always start with an analogy and then go into the mathematical detail. I think not many people understand math from just looking at equations. So I think the intuition first is
Alisa asks if it makes sense to take the same course twice.
I would.
Probably not.
All the material is online. So once you've taken it once, I definitely recommend going back and revisiting the material, but you don't need to formally take it again.
Yeah.
Anonymous attendee says their TA is going too fast. Is it fine to tell them that that's too fast? I can
Yes.
answer that. Yes, definitely. Absolutely, 100%. In fact, if you're lost, then probably most of the rest of the pot is lost just as well. Salma asks about data sets. I'm trying to find the data sets about brain scans and genetics. What data sets exists? UK Biobank. There's definitely UK Biobank has
Yeah.
Great. Ali asks, how can we keep track of and be updated about projects once NMA is over?
Like group projects, maybe. I mean, we'll leave the Discord servers open for a little bit at least. So that gives people time to offboard and move to other group chat platforms. And then like looking at micro publications for the Impact Scholars Program, there's that too.
Pasha asks which books to read. Diane and Abbott is great. Ella.
Models of the Mind is a non-textbook accessible approach by
Yeah.
Liz Lindsay, who's involved in Neuromatch. So I'm biased, but I think it's amazing.
And together with Tim Lillicrap, who's also on the deep learning thing, we're currently writing a textbook on comp neuro and deep learning, which is a little neuromatchy altogether. Sahil asks, for an undergraduate in a research institute, if you really want to explore your tech on your AI, what proportions of computational and theoretical?
There's no one
Yeah.
one fits all. It's like it depends a lot on the specifics. And again, like neurotech in particular is very multidisciplinary. Lots of engineers, lots of like neuroscience knowledge needed, lots of computer science knowledge needed, math needed. All of these disciplines can fit into a team and typically do.
Anonymous asks where they can score Gunnar's t-shirt.
I don't know if that's vintage by now. Does that still exist? This is the back.
Yeah.
Is that still on the for sale? Yeah, it is. Okay. Courtney, you should drop the link in the chat, maybe. Thank you.
And then last question is Ali asks about visa situations. Like most universities, I'll answer it here. Most universities can solve visa problems. And
If
yes,
they are solvable,
if
right?
you're from Iran, it's
Yeah.
gonna take a bit.
Yeah.
And unfortunately, that's the US reality. It's probably better in Canada.
I
Good.
will say for visa issues, like if it's just a delay, ask for a deferred start date. Make sure you start that conversation with the admissions office and with your department. There's usually a way for you to come like a term later or something if the delay is because of a visa. So we do that a lot here. If for places like, Iran, if there's a delay in the visa and it's coming, but it's just not coming fast enough. So that is a possibility and ask for that.
So I think we're about at our hour. Yeah, thanks for doing that lightning round and getting through most of the questions. We would love your feedback. I already kind of tracked some of the stuff you all shared in the chat. It's super helpful for me. Please take a quick survey for us. We do like to be super data driven and we do take all your feedback into account. So hopefully we can have more sessions like this in the future. And then I didn't write them on the slide, but I did send that message in Discord. We have 2 additional fireside chats. We have one on Wednesday with some of our deep learning creators, as well as our Neuro AI course director. And on Thursday, we have our course directors for our climate course. And then Grace Lindsay was mentioned in the chat. She is also joining along with Wesley Banfield for that one. So please join us for our other discussions as well. And thank you all for attending. And thank you all who are our panelists. It's great to chat with you and hear from all of you. So thank you so much for your time.
And
And
come
have
say
fun.
hi. Come say hi at conferences. Like, come up to us and say hi. It's literally like, Ella mentioned, it's my favorite thing too. I love it. So please come say hi. We'll
Same
see you
here.
soon.
Awesome. Cool.